Hi everyone, so today we're going to talk about side angle side and side side side, and these are ways to prove that the triangles are similar. So previously we discussed the angle angle, so today we're going to learn about these two new methods of proving that triangles are similar. So for the do now, we're going to set up three proportions, comparing the corresponding side lengths of triangle ABC and triangle A prime B prime C prime. So we have our triangles here. So we want to connect the corresponding sides first. So for my big triangle ABC, side AB, so this 2.82, corresponds with A prime B prime, which is 1.41. So now we want to match our other corresponding sides. So side BC, which is 7, corresponds with side B prime C prime, which is 3.5. And then lastly, we have side AC, which is 5.4, corresponds with A prime C prime, 2.7. So now we want to set up three proportions, and it's just to cross multiply to determine whether the triangles are similar. So here we're given three sides in each triangle. So now we want to separate proportions. So we've been talking about baby mama, so let's label this my baby triangle, and this is my mama triangle. So now I want to set up proportions baby to mama. So baby to mama. So let's first start off with our AB. We could start with whichever side we want first, but let's start off with our baby. So A prime B prime is 1.41 over my mama, so that corresponds with my 2.82. And now we want to pick another corresponding side, another pair of corresponding sides. So we just did AB, so now let's do B prime C prime. So I'm going to start with this one because we did baby to mama in the first one, and we have to stay consistent. So equals 3.5, and that corresponds with 7. So we want to cross multiply. So we get 1.41 times 7, which gives me 9.87. And then we get 3.5 times 2.82. And we get 9.87. So those two pairs of sides work together. So we want to do that again for the other pairs of corresponding sides. So now let's say I start off with this one, my 3.5, my B prime C prime. So I have 3.5 corresponds with 7, like we mentioned before. And I'm going to go baby to mama again. So I'm going to do A prime C prime, which is my 2.7. And that corresponds with my 5.4. Okay. Then we want to cross multiply again. So we get 5.4 times 3.5. And we get 18.9. And then we're going to do 7 times 2.7. So cross multiply again. And we also get 18.9. So we know those sides are also in proportion. So now we want to set up our last proportion since it says 3 proportions. So my last one, I'm going to have my 1.41. That corresponds with my 2.82. And then lastly, my 2.7 baby side to its mama side, 5.4. So now I did this last proportion because these are the only two colors that I haven't used yet. I did blue to pink here, pink to orange here. So now I want to do blue to orange. So when I cross multiply, 2.82 times 2.7, I got 7.614. And then I'm going to cross multiply this other side to check to see if we get the same number. And it turns out that we do. 7.614. So now we know that all three sides are in proportion. So are all three pairs of corresponding side lengths in proportion? We could say yes. And if so, we can say the triangles are similar by, we're talking about side, angle, side, and side, side, side today. We are given three sides in each triangle, and all three sides are in proportion. So we want to say they're similar by side, side, side. Okay. So let's take a look at example number 1. So you want to determine whether the triangles are similar here. So first, let's note our two triangles that we see here. So we see triangle ABC. So let's outline that. But we also have to find our other triangle. There's two triangles here. So our next triangle is going to be this big triangle. So I'm going to highlight this big triangle in blue. All right, so now we want to know what information is given about the triangles. So we're given two side lengths here. So two pairs of sides. We see a 4 and a 3. So we have two pairs of sides. And also, if we look at this angle, angle A is in my yellow triangle, my small triangle, my baby triangle. But angle A is also in my blue triangle. So we want to say that they have a shared angle. And that's angle A. Okay, so now we want to use a proportion to compare the corresponding side lengths and to check to see if they're valid. So before we did baby to mama. So here we have my baby side length, but we don't know my mama side length. But we know this is 9 here, and this is 4. So to find this big side length, we're just going to do 9 plus 4 and add it together. So if we do 9 plus 4, we get 13. So now we know this whole side length here is going to be 13. So that's my mama side. So the 13 corresponds with my baby side, 4. And then if we look at this side of the triangle, we know our baby side is 3. But we don't know the mama side yet, but we're given two numbers again. So we're going to add a 6.75 plus 3 together, and we get 9.75. 9.75 is my mama side. So 3 corresponds with my 9.75. So now since we have our corresponding sides, you want to check to see if they're valid. So we're checking to see if they're valid here. So we're going to set up our proportions. So baby to mama we're going to do again. So if I start with AB, that's my baby side, which is 4. And we said that corresponds with my mama side, which is 13. And then do baby to mama again. So baby is 3. And that corresponds with my mama side, 9.75. Last step is to cross multiply because we're going to check to see if these proportions are valid with each other. So 4 times 9.75 gives me 39. And 3 times 13 also gives me 39. So now we know that the sides are in proportion. So are the corresponding side lengths in proportion? We can say yes. Based on your work, are the triangles similar? If they're similar, state which similarity method. So we know that the sides are in proportion, and we know that there's a shared angle. So from looking at these three methods, the one that shows that two sides and an angle is side, angle, side. So we can say sides are in proportion and angles are preserved. So now we just prove that these two triangles are similar by side, angle, side. Okay. So for example number 2, we're going to determine whether the triangles are similar, and we have to justify our answer, and we want to say which method proves that the triangles are similar. So by looking at our triangle, so we have two triangles again, let's highlight those. We want to see what type of information we're given here. So here we have two sides in our baby triangle, and we're also given an angle. And then we also have our number 10 here and a 3 here. So to find this big triangle size, we just add them again. So 10 plus 3 gives me 13. And then we want to do the same steps over here. We have 2 and 7. So to find the whole length, we're just going to add it together. 2 plus 7 gives me 9. So we have two sides and we have a shared angle, because we said angle P is in my yellow triangle and angle P is also in my blue triangle. Then I'm thinking that we want to prove our triangles are similar by side, angle, side. So first we want to check to make sure our sides are in proportion. So we have 3 in my baby triangle corresponds with 13 in my mama triangle. So we're going to do baby to mama again. So we said 3 corresponds with 13. And then we know that 2 in my baby triangle corresponds to this side in my mama triangle, which is 9, what we figured out when we added. So we're going to say 2 to 9. So I did baby to mama, baby to mama. I stayed consistent. That's key here. And then last step is to see if the proportions are valid. So I'm going to cross multiply. And I got 13 times 2 gives me 26. And then 9 times 3 gives me 27. So we see here that the numbers are not equal. So they're not valid. But we know that angle P is equal to angle P. But is that enough information to prove that these triangles are similar? We're only given one angle and the sides aren't in proportion. So we can't prove it by side, side, side. We don't have enough sides. Side, angle, side doesn't work, and we don't have another angle. So therefore we can say the triangles are not similar. And we can say because the side lengths are not in proportion. The side lengths, they did not equal each other when we made the proportion. So because side lengths are not in proportion. Okay. So example 3 says determine whether the triangles shown are similar, justify your answer. So looking at these triangles, we don't know any information about the angles, but we are given 3 sides in each of the triangles. So let's match the corresponding sides first. So AB corresponds with A prime, B prime. We're just going to match the letters to the sides. So that means 1.41 corresponds to 2.1. Then we have A side AC, which is 5.25, corresponds with A prime C prime, which is 7.28. And then lastly, we have 6.04, my CB, or side BC, corresponds with B prime C prime, which is 8.29. So now we match our corresponding sides. So now we just want to check to see if the triangles are similar, if the sides are in proportion to each other. So before I set up in the do now, when we prove them by side, 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 I set up 3 different sets of proportions, but there is another way you can do it. So we're going to stay with our baby to mama again. So baby to mama. And I'll label these triangles. This is my baby triangle. This is my mama triangle. So now I'm just going to set up three proportions that go right across each other. So baby, so AB is 1.41. To mama, 1.41 corresponds with my other orange circle, 2.1. Equals, so I'm going to do A to C, so baby, 5.25, my pink rectangle, corresponds with my other pink rectangle, 7.28. Equals, so another fraction, another proportion, and we're left with blue left. So BC, baby, so 6.04. So this blue triangle corresponds to my mama blue triangle, 8.29. Okay. So now, we just have to divide these numbers out and see if they're all equal to each other. So we're going to do 1.41 divided by 2.1. And here we get 0.67142 continued. And now we want to see if this works for the other numbers, if they all match. So we're going to do 5.25 divided by 7.28. And we get 0.721153 continued. So from there, we already see that the sides are in proportion. But let's just check to see if this one works also. So we're going to do 6.04 divided by 8.29. And we get 0.72858 and so on. So we know the set 0.72 works, but the numbers after that change. So all these numbers are not equal to each other. So therefore, we can't say that the triangles are similar by side, side, side. So not similar. Because, and from looking at the sides, we see that the sides are not in proportion. Sides are not in proportion. Okay? So now just try the independent practice on your own, and good luck.